Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Human Eye and Colourful World. Before moving into the twinkling of stars, we have to discuss the apparent position and actual position of the stars. What does that mean? Are we not seeing the stars in their correct position? Let's see. How to explain the apparent position and actual position of stars? Suppose this is the surface of the earth and there is a boy standing here and gazing at the star. Suppose the star is here. It is coming to the earth's surface, but it cannot come directly to the eye of this child. Why? Because we have learned that atmosphere has got different layers. Troposphere, stratosphere, ionosphere, different types of layers are there, right? So in this case, different layers of atmosphere has got different optical density or a density as such. Because when we go up, the temperature is increasing or the density of the air decreases as we go up in the atmospheric layers, and also the physical conditions are not remaining the same. It is fluctuating because of the reasons I already mentioned. So what happens here is, when the light is coming to the eye of the child, it is undergoing refraction at a different positions. Okay, so each time it is passing through different layers of the atmosphere with the different physical conditions. The refraction keeps on happening and the light ray is not coming as the straight line, but it is bending towards the eye because it is moving from rarer medium to denser medium at a different levels. So for the child looking from here, the star will be appearing somewhat here. So it is not the actual position of the star we are observing. We are seeing it slightly above the actual position. That's the apparent position of the star. So apparent position of the star is actually far away and also little higher than the actual position because of the atmospheric refraction. Different layers of the atmosphere has got different density, and upper layers have got rarer density, lower has got high density. As a result, the light rays are undergoing continuous refraction till it reaches our eyes and it is seen at a different position. Now, the light coming from, as I told, star is very far away from our eye. So the source of light is considered as a single point source of light. Okay, so the light, if it is falling here, the next moment the first ray came here. Second ray, when it comes, it may not be coming in the same path. It will be deviating. Why? Because the physical condition keeps on changing. So in that case, it may not come to our eye, or the complete rays may not reach our eye. The next time again the light ray is falling on our eyes, next it is not falling on our eyes. So it is looking like a twinkling. It is becoming brighter when we get all the rays into our eyes, but sometimes all the rays may not reach our eyes, it gets refracted, so it is becoming it is fading away. Then again it becomes brighter. So this is called the twinkling of stars. So which phenomenon can explain the twinkling of stars? The atmospheric refraction. The apparent and actual position of the star is also due to atmospheric refraction. So when the light rays are passing, the star is considered as a point sourced object or the source of light. So the light may not fall on our eyes continuously. Its amount will vary. So it is called a flickering or the twinkling of stars. When we consider another object, celestial object, that is the planet. The planets do not twinkle, whereas stars twinkle. Why? Because those stars are larger than planets. They are far away from us. Due to the distance, we are considering them as a single point source of light. But when the planets are considered, they are closer to us and larger. So they are considered as extended sources of light. So many rays are coming from the planets at a time. So these lights, suppose half of the light falls on us also, we will be able to see the planet. Next moment atmospheric refraction happens, another 50 may come to my eye, the first 50 may not be there, but still I can see that. So any point of time, some or the other rays will be reaching our eyes, though many will not be reaching. Because if it is only one, means either coming or not, right? But many are there, options we have. If one is not there, at least we get from the other. So it's like a backup. So every time light is coming, so we don't find the planets as flickering or a twinkling. So that's the reason why the average variations happen by the refraction of a different sources will nullify, or it will average out to zero in the case of planets. That's why we don't see planets twinkling. This is the horizon, and if a person is here, when the sun is here, that means it has not crossed the horizon and come up, but before that itself, for this person, the sun will appear here. It's sun, not a sun is a star, but sun will appear here. That is 2 minutes earlier. Okay, it will take another 2 minutes for the sun to come here, but due to atmospheric refraction, again it is bending, and it will reach the eye even before it is actually above the horizon. So we get 2 minutes earlier the sunrise every single day. The same way, evening also what happened? Sun has already set, but still for us, due to this refraction, we see that sun is here. So 2 minutes after the sunset also we can see the sun. So due to atmospheric refraction, this phenomenon happens. The physical condition of the atmosphere keeps changing. Due to that, the light entering the atmosphere undergoes complete or continuous refraction. This will lead to these phenomena. That is, 2 minutes earlier we can see the sun, that is 2 minutes earlier than the sunrise, and also after sunset 2 more minutes we can see the sun. This is due to atmospheric refraction. Now we are moving on to a third phenomenon of light called the scattering of light. First was bending of light, that is called a refraction. Second was splitting of light, that is called a dispersion. Third is a scattering, that means just a spreading out. Scattering means what? Suppose you have the Chinese fan, right? When we are splitting open the fan, we can open it, that is the inside is visible. So that is called a dispersion. Okay, after that we fold it, that is refraction. But if I have a chain of beads, by mistake it falls from my hand and it breaks, you can see the beads will spread everywhere. That is scattering. Okay, so scattering of light also can lead to different phenomena that we observe in our day-to-day life. First one we will start with the Tyndall effect. Tyndall effect is happening to colloidal solution. Colloidal solution means what? There are suspended particles which are very small. So when we are passing light, these particles can scatter the light. As a result, we can see in which way the particles are moving. This phenomenon is called a Tyndall effect. So the scattering of light by the colloidal particles is called a Tyndall effect. This is also observed in our day-to-day life. Sometimes in our homes we can see when the light is entering through some windows or doors, if there is smoke, the path of light may be visible, or if there is dust, the path of light becomes visible. Why? Because these smoke particles or dust particles or even water droplets are there. This is possible. That is happening in the canopy of the forest. If you are walking through the forest, or you can see at least in pictures that when the light is entering through the canopy, it is undergoing this phenomenon of Tyndall effect. Why? Because there are lots of water droplets, they are scattering the light particles and we can see the path of light. When we were small, when we used to go to watch movies, in the theatre, they would be projecting it from behind. Because of the dust particles in the theatre, we could always see the path of light. Now in the theatres, it is fully digital, so we cannot see the path of light in that way. Okay, so at home also you can observe this. Next time when you go to the kitchen in the morning, just see if you are cooking something, the smoke can lead to Tyndall effect. Here what happens is the particles are scattering light. But what color we will see this light? The color depends upon which particle or which type of particle is scattering. Now we told there are 7 colors in the video. Red is having a wavelength like this. Imagine the waves are longer, so we can say that wavelength is very high for red. Okay, but when it comes to the other lights, that is Vibgeo, violet, orange, yellow, green, it reduces. When it comes to violet, it is very small waves. So wavelength is decreasing in the case of violet. When a small particle is on the way, so the light is coming with a red, orange, yellow, violet, all having different wavelength in it. you can see that if the particle is very small, what happens is the longer wavelength will pass through it or pass over it, whereas the shorter wavelength will come and hit on it and get scattered. So which light can scatter easily? The lowest wavelength, violet, indigo, blue range. So we see this as blue color. This is the reason why the clear sky appears blue. Sometimes when we look at the sky, if it is clear, it is appearing blue. Why? Because the smaller particles of dust and other things in the atmosphere scatter all the blue lights. So the blue light is spreading over there, that is why it is appearing blue. The other lights are all escaping, other rays are all escaping because they are not getting scattered. But when it is in the evening, okay, so daytime the sun is very close to our surface. But evening and morning, the distance is more. So when this light is coming far away from our eyes itself, the blue range of lights, that is violet, indigo, blue, all those will scatter away. Who will only reach our eyes? The longer wavelength rays like a red, yellow, orange. That's why the horizon appears reddish, yellowish and orange in the evening and in the morning. Rest of the time we don't see it red because that time the sun distance is becoming lesser, so blue light gets scattered and it is visible to us. Another thing, if this particle is big enough, all the rays will get scattered, including red will get scattered. So if all are scattered together, it appears white. So if the scattering particles are small in the atmosphere, they scatter the lights of smaller wavelength like blue. Whereas if it is larger particles, they will scatter all the lights, that is what the white color will be seen at the end. Just now I mentioned the clear sky appears blue. Sometimes it appears white. But when is it appearing white? There are large particles which are scattering all the rays of light, it becomes white in color. But imagine a situation if there was no particle or no atmosphere. If there was no atmosphere, there would not have any scattering of light. We would have seen the sky dark always. So atmosphere, if not there, the sky would have appeared dark to everyone. But even now, those who are flying at high altitude, especially the space travelers, they see it as dark because at a height there is no particles to scatter light. Scattering of light is giving the color. If scattering of light is not there, there is no color, it is dark. Another thing, we have learned or we have read stories that if there is a problem in the railway track, people would be using their red shirt or red cloth to get the attention of the loco pilot to prevent the danger or prevent the accident. Or the signal lights, when we want to stop, that is red in color. Or any danger signal, it is red. Why are we using red for danger? Because red, as I told, has got a longer wavelength. When the wavelength is high, the ability to scatter is less or chance of scattering is less. So it can travel far distances and reach our eyes. So if I show a blue color dress or blue color, it may not be visible to a person who is far away from us. But at the same time, if I use a red piece of cloth, it will be visible because the light will reach his eyes without much scattering. So these are the important points you have to study in this chapter. You have to clearly distinguish between refraction, dispersion and scattering of light. What are the phenomena associated with it? Whenever you are explaining a phenomenon, you have to say what is the associated light process also. That is whether it is due to refraction or it is due to reflection or it is due to dispersion or it is due to scattering. If you like my videos, please do me a favor. Share it in your class group or with your friends. Make them also learn the lesson with you. And give a comment if you have any doubt or suggestions. If you have not subscribed yet, please do consider subscribing to my channel. Thank you for watching Biology My Passion.